All right, hello guys, and this will be hopefully this will be our last lesson that I need to do a video. I'm coming back next week, all right? Um, so last lesson we've learned the standard score, all right? So standard score is z equals x minus mu divided by standard deviation. Standard score is very useful to compare the relative performance to the whole group if the whole group is in the distribution of that group is in normal distribution. This lesson we are going to learn the normal probabilities. How can we find the normal probabilities? Okay, so first of all, just have some very quick reminders. For normal probabilities, you can consider the standard normal or the general normal. Okay, the only difference is standard normal, so they both are using bell shape, we know that. Sorry for the drawing. For the standard normal, the mean must be 0 and also standard deviation must be 1. For general normal, it's not a very good drawing, sorry. It's sometimes difficult, it's tricky to draw it on a mouse. Okay. For general normal distribution, it's more like we don't really know where is the central point, which is the mu, and also you don't know how large is the standard deviation. It could be anything, all right? So it could be any value from the mean and also for the standard deviation sigma. But pretty much they are using the same idea. And to find the probabilities, we've learned that in the continuous normal distribution, we can use the integration of the density function to find the probabilities, right? But in normal probabilities, it's quite impossible to use integration on that density function because density function is very difficult to integrate. So that's why, and that possibly the good news, we are going to find the probabilities most likely in paper 2, and you can use your calculator. So this lesson I'm going to show you how can you use calculator to find the probabilities. Just like for the first one, you're going to find the probability for a z is a standard normal random variable. You need to find the probability for z between -1 and 2.5. If I try to draw it visually on that bell-shaped curve, I'm going to use a standard normal curve from -1 here to 2.5 here. And you need to find the area here. Area under the density function means probability, okay? But how can we do that? First of all, you need to use your calculator. Can I ask you to switch on your calculator? Get you ready? Okay, you can pause the video if you need some time, just let the teacher know. Oh, good. I make a mistake here. For standard normal random variable, it's not just 1. Mu is 0 and sigma is 1. And that's a few things you need to do. You need to use normal CDF. Use normal CDF, then there will be a lower bound, upper bound for you to put in. All right. Then after that, I think that's and then you will get the value. But let me try to use calculator to show you. Okay. You can just say probability, Oh, okay. Probability minus 1. Okay, right, then you will get it. Right, so let's look at part B. Part B is z greater than 1. So the problem with that one is if I draw the bell shape, and here is the standard normal. If I'm saying I'm going to find z greater than 1, so 1 is here. So what I'm going to find is the area under the curve. So the problem here is you can see there's no upper bound. You have a lower bound, but you don't have an upper bound. What would be the upper bound? So in theory, the upper bound should be infinity. Should be infinity if you extend your axis to infinity. But how can I input an infinity in the calculator? According to the textbook, you can use 9. E just means 10 to the so E just means 10 to the power of something. Okay, so there are a few ways to do it. So you can use control and that symbol then there will be a template of values for you to use. But I would say we can try different large value to see if you can still get the same answer. I guess so. And so let's go back to our calculator. So remember your lower bound is 1 and then your upper bound is infinity. Oh, sorry, that's not the. So you can write down your answer over here. If that's free silicon figure, okay. Right, let's do the general normal. General normal, that means we can give you any mean or any standard deviation. So you need to track for the mean and standard deviation. So remember that for standard normal, they are not going to give you the mean and standard deviation. So you need to remember for standard normal, mean must be 0, standard deviation must be 1. But for general normal, it could be any values. So you need to check. Mean is 4, standard deviation is 2. So mean, I use the symbol to represent them. All right. And you can see I show you how can we do it over here. So if you use mean equal 4 and standard deviation 2, you just do the same thing. You can try now. You can try to use your calculator to see if you can get the same thing. Okay, so if I'm too quick, you can ask a teacher to pause the video for you anytime. All right, so that means you need to write down your answer like let me check. Okay, is 0.x less than 6, which is if I use 3 decimal places or 3 silicon figures. All right, and how about part B? We try B here. So for B, you need to find px less than 1.5. So remember for x less than 1.5, okay, let me draw the normal distribution. Mu is 4 and standard deviation is 2. So 4 is here. Okay, so let's say this is our the normal distribution. X less than 1.5. So where's 1.5? Let's say it's around here. Less than 1.5 should be the area under here. Again, you can see you can go to infinity. But this time it's not positive infinity, but negative infinity here. Okay, so for that one, the upper bound is 1.5, but the lower bound is negative infinity. Right? So let's go to the calculator. Is 0.106. Right? No problem. Okay, I think that part is not the most difficult part. But next we are going to find the okay, I missed the title here. So what I'm going to do next is to determine normal percentile given the probability. So what you're going to find is, for example, if I give you the area on the left hand side of a certain boundary K, if I give you the area 0.7, how can you find the value of K? So in terms of probability statements, it would be in the form of like, okay, probability x less than equal to k equals 0.7. Okay, and you need to find for k, you solve this one for k. And to do that, we need to use calculator again. But this time, we need to use another calculator function, which is called the inverse normal. Just give you one example. For example, when x is normal distributed with mean 100, standard deviation sigma 6, find k such that probability x less than equals k equals 0.95. Right. Remember, the target is to find k. The target is to find k. So in your calculator, you need to go to distribution, but this time you need to go to inverse normal. That should be the number 3 of the function list. And then you need to go for 3 inputs. The first one is your area. That means the area on the left hand side of the boundary. And you need to find the you need to input the mean and also the standard deviation. Then a value would be automatically generated for you. All right. Can you try to do this by yourself? I will give you a couple minutes. Try to do it. All right. So from calculator, it's up to you if you want to copy the screen, but I think that's a good practice to copy from the screen of your calculator to show to show people how you find the value. All right, then you find the k value. K value is 7.615. That's how can you find the k value. Is that okay? Okay, let's have a look on the next one. So the next one, again, is a normal distribution. Okay, here's 10. And let's draw it a little bit here. Okay, and you need to find from 6 to k. K is unknown. So 6 is here. Where is k? We don't know, but you see the value is 0.48. Okay, so it's a bit embarrassing because we don't know where is k. It certainly should be on the right hand side of 6, but whether that k would be on the would be larger than 10 or smaller than 10 is hard to tell because that number is very close to half of the area. If that number was significantly greater than half of the area, means 0.5, then you know it should be on the right hand side. If that number is much smaller than half of the area, then it should be on the left hand side, but that's a marginal case, isn't it? So let's just guess. Sometimes you have to make a guess. Let's guess is around here. Okay. Then what you're going to find out is the area here, which is 0.484. But the problem is we need to find k, right? We need to find k, but given the area is 0.48. Can we use inverse normal from this step? We can't. The problem is we can only find the area on the left hand side of k to the negative infinity. Let's go back to this graph. You see, you need to go find the area given need to be on the left hand side of k all the way to negative infinity. There must be no lower bound, but there is a lower bound right here. Okay, so what can I do? There are a few ways we can do it, because we can think if we're trying to find the area on the left hand side of k, 0.4 is part of it, but the other part is from the left hand side of 6, right? So, and do we know that area? We don't. It's not given, but we know in the calculator you could find that would be x less than or equal to 6. All right. So can we say that the probability of x less than equals k, I mean the total area on the left hand side of k equals 0.48 plus the blue area px less than equals 6. So that means we need to find one value first before we can find the k. So how can we find the value of px less than equals 6? So let's go. So remember, for this one, you need to use calculator. You need to use CDF. All right. and you need to use CDF function in the calculator. With what? You need to use the mean is 10. Standard deviation again is 2.5. And the upper bound is 6. How about the lower bound? There's no lower bound. The lower bound is negative infinity. So let's use the calculator to find this part first. Sorry. Let's go back here. So I'm going to copy the previous value for this one, which is 0.054799. Okay. Then can we use calculator to add these two values together? All right, then you will get 0.534799. All right. So what value will be k? So here, because you've already got x less than equals a k value, which the whole area 0.534799. So we can use inverse normal again. To use inverse normal, your mu need to be 10, standard deviation 2.5, area 0.534799, and your calculator, you need to use inverse normal. Okay, what value I'm going to input? Okay, the first number in the inverse normal in the calculator, you need to be the area. So the first number you're going to put in is that number. The second number is the mean, which is 10. The last number, standard deviation. Okay, let's try to do this. So you find k equals. Right, that's it. So let's track the reasonableness. So k is a little bit bigger than 10. So which agree with our initial guess. But even your guess is wrong, that doesn't matter. It should be very close to 10. If you go back to our previous question, the k is 7.615. So actually that k is lower than 10. So that means it's reasonable. Okay.